The next important term I would like to quickly review is scaling. When looking on a typical software application, one of the main challenges to take into account is system scalability. Scaling is the process of managing the underlying IT resources being used by the application to meet a set of performance requirements. IT resources like computing power, memory, storage, and networking. When there are not enough available IT resources to handle demand, traffic demand, there is a chance to impact the application's requirement. Or when there are too many resources that are not used, in some point of time, we will waste money on underutilized resources. It is a careful balance. The goal is to meet our defined performance requirements while optimizing the utilization of the IT resources. And in most cases, this is an ongoing process. Applications are going to write data to the database and then read that data from the database. In a growing amount of cases, we are talking about a massive amount of data. Any delay in processing a request and providing a response will dramatically impact the application using a specific database. So databases are considered to be one of the main bottlenecks of applications because data is typically stored in disk that are much slower than a computer memory. It is extremely important to scale database components to prevent such performance issues that are impacting application. So scaling IT resources is essential. That's clear. But what kind of options we have? Well, there are two main options when performing scaling: vertical scaling and horizontal scaling. Let's start with vertical scaling. Vertical scaling is also called scaling up or down. Scaling up is the act of adding more IT resources to a single specific computing node, okay? The most relevant resource type is, of course, a virtual machine or maybe a physical server. When allocating a virtual machine, we are explicitly selecting a computing profile, meaning the number of CPUs and memory capacity of that virtual machine. Scaling up is about adding more resources, such as CPU or memory, to a single instance. And also the other way around. Scaling down is reducing the amount of CPU and memory. In many cases, such a vertical scaling is a useful option to solve all kinds of performance issues. Just increase the memory capacity or add more CPU power in a specific virtual machine, and you can quickly solve some performance bottleneck. So if we have a database running on a virtual machine, we can scale that up and down. On the other end, vertical scaling has some disadvantages. We can't always increase the resources of a virtual machine. At some point of time, we'll encounter some limitation in the underlying IT environment. Okay, or maybe moving to a bigger machine will be so costly that it doesn't make sense. Another disadvantage is that when we choose to scale up or down a virtual machine by selecting a different instance size, we need to reboot that virtual machines, okay? Meaning reboot the database that is running on that virtual machines. And this is not always an acceptable situation, especially if we need to change capacity in a high frequently intervals, okay? Let's say that we need to change the scale up and down every few hours, okay? It doesn't make sense. Okay, can you think about an application that accept that the database will not be available because the server running below must perform a reboot? Okay, it's a problematic situation. If we are doing the scaling once a week, okay, maybe that's okay. But if we plan to scale the system every day or even every few hours, it's not acceptable. The next scaling option is horizontal scaling, also called scaling out, okay, or in. Scaling out is about adding additional nodes to support the load on some cluster. Instead of adding more capacity by making a specific node more powerful, okay, we add the power by increasing the number of nodes. Okay, it is called distributed computing. Instead of allocating a much more powerful virtual machine, as we are doing in a vertical scaling, we can add smaller virtual machines running as a cluster in parallel. The application can better distribute the traffic load on multiple instances that are performing the same function. Okay, it can be more linear growth, which will be translated into more cost-effective option. Now, why this is necessary in our training? Okay, talking about scalability. Well, one of the biggest challenges in database is about scaling. Okay, applications are using much more data today. The load on many applications is dynamic, and traditional databases are not doing a great job when we talk about scalability. We'll see later on, but the development of new database technologies was driven mainly by the requirement of providing also horizontal scaling and not just vertical scaling.